Pluto is relatively far away and dim, a small astronomical object that was once considered to belong to our solar system. Despite recent and surprising announcements by leading space experts Neil deGrasse Tyson and Michio Kaku, Pluto has been brought back to the forefront of attention. They suggested that this remote body could potentially be on a likely crash course with Neptune. They aren't merely hypothesizing, they're issuing a warning. This miniature world may be heading straight for a catastrophic encounter with Neptune. But how could such a thing be possible? And what would the aftermath be if an enormous impact like that truly took place? Are we seeing an odd cosmic illusion, or is something far more tangible and far more alarming speeding toward us? The dangerous Pluto's path comes close to Neptune's. Neil deGrasse Tyson and Michio Kaku are raising the alarm. If there's even a slight adjustment, we could be facing a devastating planetary accident. Might Earth be at risk as well? More crucially, how could such a cosmic occurrence even come to pass? Join us as we delve into the possible consequences of a Pluto-Neptune collision. Pluto, once officially a planet but later downgraded to a dwarf planet, remains a source of intrigue in the vast universe, as demonstrated by current models from leading researchers. Pluto's path passes perilously near Neptune's. Renowned Neil deGrasse Tyson and the astronomer Michio Kaku are both alerting the world to a potentially dangerous interaction between these two bodies, which could imply a substantial hazard for Earth. Yet, how could this scenario unfold? Pluto's journey is unlike any other around the Sun. It is another body in our solar system that orbits it, taking an incredible 248 Earth years to complete one revolution. Since its discovery in 1930, it hasn't even made one full orbit. Still, the intrigue doesn't stop there. Pluto's orbital path is highly stretched out, much more so than the generally circular paths of the main planets. Even more fascinating is its orbital inclination, a tilt of 17 degrees compared to the Sun's plane. What happened to Neptune? This trajectory is far more irregular than those of the other planets, adding layers of complication to Pluto's movement. Conceivably, one of the most intriguing aspects of Pluto's route is that it intersects Neptune's orbit for about 20 years in each orbital cycle. Pluto is actually less distant from the Sun than Neptune during this time, defying what we'd expect based on their standard positions. This raises the usual question: why haven't they collided? The answer lies in the gravitational effects of nearby celestial giants. Studies into Pluto's path began soon after it was found. Early astronomers attempted to make sense of its odd orbit. While most planets follow loops that align with the Sun's plane, Pluto's trajectory is slanted and uneven. The puzzle grew deeper when scientists realized Pluto's orbit crosses that of Neptune. The stability of Pluto's motion, despite these bizarre characteristics, demonstrates the subtle intricacies of space mechanics. The three-body problem, understanding how three celestial objects like Pluto, Neptune, and the Sun influence one another through gravity, is central here. It's like predicting future positions based on their initial placements and mutual gravitational pulls. In Pluto's case, this complexity reveals how its movement, Neptune's orbit, and the Sun's pull all work in an interlinked system. Terms like asynchronous oscillation, orbital drift, and VZK wobble are key to decoding this riddle, as highlighted by astrophysics experts. What helps maintain celestial bodies on their stable routes is asynchronous oscillation. In Pluto and Neptune's case, this means that when Pluto is positioned at least 90 degrees away from Neptune, a safe angular buffer, it prevents a crash. Orbital drift, on the other hand, involves the vertical movement of a body as it moves around Pluto. This suggests that when it draws close to Neptune or another large planet, it is far above their orbital paths, adding another safeguard against potential impacts. Another important factor is the VZK wobble, named after researchers Zell, Kai, and Kaku, who studied the gravitational interactions of space objects. It describes how three massive entities like Pluto, Neptune, and the Sun exert forces on one another, influencing their movements. In Pluto's situation, the VZK wobble offers insight into why its orbit near the Sun appears erratic. Even though its path may seem unstable, this wobble helps keep it smoothly orbiting over very long periods. The VZK wobble shows that while space may seem chaotic and unpredictable, underlying principles still maintain a degree of stability. These forces support Pluto's consistent motion, preventing a Neptune collision. The James Webb Telescope's stunning observations, while deviating, highlight this three-body dynamic, which is vital to understanding how orbits shift due to gravitational interference. Studying it gives us more clarity about Pluto, our planetary group, and even distant galaxies. Computational models from the 1980s indicated that while Pluto's orbit is stabilized by certain features, it still exhibits unpredictability. Minor changes in starting conditions can cause major deviations over centuries. Still, Pluto's orbit has remained steady over remarkably long durations. Modern automated data has allowed us to better observe how the massive planets Neptune, Jupiter, and Saturn influence Pluto's journey around the Sun. Pluto and Neptune share a special orbital rhythm. For every 2 laps Pluto makes, Neptune completes 3. This synchronicity aids in Pluto's route. But Neptune isn't the only player. Jupiter's powerful gravity plays a major role in keeping Pluto's path stable. Saturn also contributes. Studies show that Jupiter's mass is sufficient to help maintain Pluto's trajectory for possibly billions of years. It appears that Neptune, Jupiter, and Saturn are collectively working to ensure Pluto travels safely through space, avoiding danger. These unusual but vital systems are crucial to keeping our solar system intact. Space would be vastly more chaotic without them. Pluto and other more chaotic objects might crash into others or be expelled from the system, creating chain reactions across the cosmos, particularly in Pluto's case. Concerns about future encounters with Neptune make understanding its movement essential. This gives us a clearer view of the ever-changing dynamic nature of our planetary family. Pluto's case shows how even seemingly unstable orbits can achieve harmony by means of intricate gravitational and kinetic equilibrium. It also emphasizes the need for constant observation and analysis of these anomalies to better understand our place in the universe. Exploring the outer realms of space frequently confronts us with the strange nature of celestial phenomena. Pluto's orbit is a perfect representation of such irregularity. The concept of orbital chaos, which refers to how orbits are highly sensitive to their starting conditions, is clearly at play here. For Pluto, this means that even tiny changes in its speed or position can dramatically alter its long-term path. Using computer simulations has greatly aided scientists in examining Pluto's behavior. These tools employ formulas to reproduce how Pluto and planets like Neptune interact through gravity. By altering the initial variables, researchers can observe changes and better predict future orbital shifts. By analyzing these simulations, scientists gain valuable insights into the complex gravitational dance between Pluto, Neptune, and other celestial bodies. This helps them anticipate potential deviations in Pluto's orbit that could increase the risk of a close encounter, or even collision, with Neptune. Such an event would not only reshape the orbital dynamics of the outer solar system but could also have ripple effects throughout the planetary neighborhood. While the likelihood of a catastrophic collision remains low due to the stabilizing influences of Neptune, Jupiter, and Saturn, even minor gravitational disturbances, caused by passing objects or internal perturbations, could alter Pluto's trajectory over millennia. This underscores the importance of ongoing observation and refinement of orbital models to detect any early signs of instability. Moreover, understanding Pluto's behavior sheds light on broader cosmic processes. The principles governing its orbit apply to countless other small bodies in the Kuiper Belt and beyond, where chaotic orbits and gravitational resonances shape the architecture of the solar system. These studies contribute to our knowledge of planetary formation, migration, and long-term stability. In addition to the scientific intrigue, the potential risks associated with Pluto's path have sparked public interest and concern. Prominent voices like Neil deGrasse Tyson and Michio Kaku emphasize the need for vigilance and preparedness, reminding us that even distant celestial bodies can pose challenges. Their warnings encourage the advancement of space monitoring technologies and international collaboration to safeguard our planet. In conclusion, Pluto's unusual orbit is a fascinating case study in celestial mechanics. It highlights the delicate balance between chaos and order that governs our solar system. While the possibility of a Pluto-Neptune collision remains hypothetical, the scenario invites us to deepen our understanding of gravitational dynamics and the ever-changing nature of space. Through continued research, observation, and technological innovation, humanity can better appreciate and protect the cosmic environment we inhabit. How even minor adjustments may completely change the location of Pluto. In the 1980s, digital models unveiled a startling feature of Pluto's orbit. Despite built-in stabilizing factors like asynchronous oscillation and orbital drift, Pluto's journey can still act unpredictably. A slight difference in its starting point or speed could produce drastically different results in Pluto's path. However, in just a few years, Pluto's path has held steady over billions of years. This indicates that underneath its erratic appearance lies a hidden consistency. Predicting the motion of celestial objects, especially those with erratic orbits like Pluto's, remains an enormous obstacle. The inherent instability of such systems makes theories on the object's origin and long-term predictions full of uncertainty. While mathematical models are useful instruments for comprehending and predicting space dynamics, they also show our limitations. These calculations rely heavily on accurate starting values, and even a small error can lead to drastically different results, making precision very difficult. Beyond the unpredictable nature of orbital paths, Pluto also represents the continual movement and transformation within the cosmos. Despite humanity's considerable achievements in astronomy, Pluto's unusual behavior reminds us how much we've yet to learn. Studying how massive planets shape Pluto's movement helps us understand solar system dynamics better. It shows that each planet's mass and location can significantly influence others. So, why are high-profile astrophysicists suddenly worried about a potential Pluto-Neptune impact? Despite all the cosmic mechanisms designed to avoid it, Neil deGrasse Tyson, a celebrated scientist and leading voice in public astronomy, offers a unique take on our planet's puzzles, in particular, Pluto's unusual story. Tyson, known for advocating Pluto's reclassification as a dwarf planet, provides insightful commentary on how our understanding of orbits and the solar system evolves over time. He doesn't see the change in Pluto's status as disrespectful, but rather as a necessary correction based on growing scientific knowledge. Tyson believes that learning and adaptation are central to grasping complex orbits. He views trajectories like Pluto's as a sign of how much more there is to discover. The wonder behind such mysteries keeps astronomy exciting. Yet, while Tyson is generally optimistic, his view of a potential Pluto-Neptune collision is far more sobering. His concern about Pluto's fate, once an official planet, stems from his awareness of orbital instability. He acknowledges that Pluto has stayed safe so far, but even tiny changes accumulating over time could lead to disaster. Pluto's orbit, especially its overlapping section with Neptune, forms a fragile cosmic rhythm that may not last forever. Tyson argues that even minor shifts in Pluto's movement could lead to major consequences over thousands or millions of years. These disturbances could cause chaos or even a direct collision. Though this isn't a threat right now, rather it is a possibility as it develops over time, far beyond human civilization. Still, Tyson's cautious tone stresses the importance of continued vigilance and further study of Pluto's orbit. Tyson isn't alone. Additionally, the world-renowned theoretical physicist Michio Kaku sees possible chaos that could occur as a result of planetary interactions like this. Kaku is amazed by the universe's vastness, but he also understands the fragile balance of the planet's systems and unpredictable outcomes that may arise. Both Kaku and Tyson emphasize the importance of relentless exploration into the invisible forces guiding orbital paths and the long-term future of our solar family. In its final form, Pluto's circumstances reflect how our knowledge of the universe is in constant motion. Each discovery opens new questions as astronomy advances. The slight chance of a Pluto-Neptune impact serves as a humbling reminder. The universe is full of surprises, and even seemingly peaceful planetary paths can shift drastically over time. Pluto's lessons inspire us to keep looking up and to continue pondering the mysteries stars have yet to reveal. As we deepen our exploration of the cosmos, Pluto stands as a symbol of both the limits and the potential of human understanding. Its unpredictable orbit challenges scientists to refine their models and embrace the inherent uncertainties of celestial mechanics. This pursuit drives innovation in computational methods, observation technologies, and theoretical physics. Moreover, Pluto's story is a reminder that the solar system is not static. It is a dynamic environment where gravitational forces continuously reshape planetary paths. The delicate dance between Pluto and Neptune exemplifies this cosmic interplay, illustrating how even distant objects can influence each other over vast timescales. Looking ahead, future missions and telescopic observations will provide more precise data, helping to unravel Pluto's mysteries. The possibility of discovering new dwarf planets or other distant bodies in the Kuiper belt adds further complexity to our understanding of solar system dynamics. Each new find may recalibrate our models and theories, reinforcing the idea that science is an ever-evolving dialogue between knowledge and discovery. In the broader context, Pluto's narrative encourages humility in our quest to comprehend the universe. It urges us to accept that some answers may remain elusive for generations, while inspiring continual curiosity and wonder. Through this lens, every orbit, every anomaly, and every unexpected event is an opportunity to learn and to expand the horizons of human knowledge. Ultimately, Pluto's voyage through space is more than a scientific curiosity, it is a testament to the ongoing journey of exploration that defines humanity itself. As we watch its path, we are reminded that the cosmos is a vast, mysterious realm, always inviting us to look deeper, think bigger, and imagine further.